the farmer wishes to enclose a rectangular region. He has 120 feet of fencing. So let's underline this. One piece of information we need. And plans to use one side of his barn as a part of the enclosure. As you can see, the picture illustrates that. And here it says, let X represent the length of one side of the fence. So if I assume that this is X, the width, the other side also must be X then. And the rest would be subtracting from the total number of feet of fencing we have. We have 120 feet, so the rest must go here. So if you have X and X, we're not going to use this side here. So it would be 120 minus 2X. Again, then we want to find all these different parts. For part A, determine a function A that represents the area of the region in terms of X. So let's take a look at that. So area, we all know, is equal to width times length. You can start with that formula. So in this case, A of X, area in terms of X, then would be equal to the width, which is X, times the length. We already figured is 120 minus 2X. So this would be the formula they're referring to. So in this case, if I go ahead and distribute this, I would get 120X times minus 2X squared. If I write them in order, would be A of X. The formula they're looking for, area in terms of X, then would be equal to minus 2X squared plus 120X. That's part A. Now, for part B, they're asking, what are the restrictions on X? Well, that should be pretty obvious. X is positive number. That's one restriction I should mention here. So X must be greater than 0. That's one restriction right there. The other restriction is also 120 minus 2X also has to be greater than 0. Okay, the rest came here. So 120 minus 2X must be greater than 0. So what that means is if I subtract 120 from each side of the inequality, then that would give me minus 2X is greater than minus 120. In order to solve for X, to find the restriction, you divide each side by -2. When you divide by negative, what do you have to do? Direction of inequality, anyone? Switch them. You switch the direction of inequality, so X would be less than minus 120 over 2, which is 60. So the other restriction here would be X has to be less than 60, greater than 0. So putting that together, so the restriction would be X has to be between 0 and 60. So that would be part B. For part C, it says graph the function in a viewing window that shows both x-intercept and the vertex. So when you plug the equation into your graphing calculator, make sure the windows for x and y axis are properly set. So you can see the x-intercept and the vertex. So in this case, if I set my x-axis to be between 0 and 100 and y-axis between 0 and 2000, you can clearly see the vertex, the location of the vertex, and also you can see the location of the x-intercept. So that would be for part D. It says interpret 18 and 15, 12. So if this is a given point, it means if an x is equal to 18, y is equal to 15, 12. So what that means is if you remember what x was the width of the rectangular or the parallel side of the fencing. If it's measured 18 feet, the area of the enclosed should be equal to 1512 square feet. So this can be written as A of 18 is equal to 1512. So if you actually substitute for each x 18 in the formula that we find, and then you can see the number appears there, exactly the one we see. So for part E, they're asking you what is the maximum area the farmer can enclosure. So that in this case, the maximum area would be, remember the A of x equal to minus 2x squared plus 120x, where A is equal to minus 2 and the B is equal to 120. Remember when you find the maximum area for parabola is really relocating the vertex, right? If I find the vertex, that would be my maximum area. And we have a shortcut for finding a vertex. V of x position of the vertex is equal to minus b over 2a. Make sure everybody remember this. So in this case, that's all I have to do is just substitute for each b 120, for each a negative 2, and then you can see v of x would be equal to 30. So that means that is your maximum point or the vertex. So if at x is equal to 30, if I plug it back into that formula, the maximum area can be calculated being 1,800 square feet. So the farmer can enclose a maximum of 1,800 square feet if the site that we have is the width is 30 feet. And we can easily confirm all these by looking at your data on your calculator. As you can see, the maximum of height of the area would be 1,800 when x equal to 30 here. And all those calculations can be confirmed looking at your graphic calculator. Okay, here is another application problem. Here we have machine produces rectangular sheets of a metal satisfy the condition that the length is 3 times the width. Okay, we're gonna remember this information here, that the length is 3 times the width. Furthermore, equal size squares measured 5 inches on a side can be cut from the corner so that results into the pieces of metal can be shaped into a box, open box, and folded up the flap. So let's take a look at the figure here. So these are what we want to find. For part A, we want to again find the function V that expresses the volume of the box in terms of the width x of the original sheet. And then we're going to look at the other parts. So for the first part, let's picture this. They're saying that, remember it says the length is 3 times the width. So I'm going to assume that the width is equal to x. So the length would be 3x. That's the first piece of information I had. And then we're going to cutting this corner 5 on each side, okay? So what that's going to happen here is the inside, this measurement here would be 3x minus the 2 of these 5 inches that we're cutting from the edges, okay? So it would be 3x minus 5 plus 5 would be 10. So from here to here would be 3x minus 10. Similarly, the width would be x minus 5 or x minus 10. So the volume then would be the length times height times width. Okay, so we know that the height is 5, and we already figured the length and the width. The length is 3x minus 10. That is my length, and the width is x minus 10. That's pretty much this is the polynomials we need to multiply to find the volume v of x, the formula v in terms of x. And everybody should know how to multiply these and then proceed. So you can take the first one, 3x minus 10, and then maybe you can distribute this 5 first and just say 5x minus 50. Then go and multiply term by term here and combine like terms. I'll let you do that. And then you get v of x add the like terms, you get 15x squared minus 200x plus 500 once you do that. Okay, that's how you find the formula. For part B, they're asking you to, again, find the restriction must be placed for x. Again, the restriction comes from that 3x minus 10 must be positive. One restriction is 3x minus 10 must be equal to a positive number. So from there, you can solve for x, subtracting or adding 10 to both sides of the inequality here. And you can divide each term by 3. So that would be one restriction right there. X has to be greater than 10 over 3. So that approximately would be like 3 point, x must be greater than about 3.3. And then with the other side, x minus 10 must be also greater than 0. So that would give me x has to be greater than 10. So it has to be greater than 10, greater than 3.3, so it must be greater than 10. So this would be my restriction. All the number from 10 to infinity, that would be the restriction. The restriction should be pretty easy to find. So all you have to do is just make sure the length and width are positive. So for part C, they're asking you that if specification call for the volume of such a box to be 1435 cubic inches, what should be the dimension of the original piece of metal be? Okay, so we basically let the volume be equal to this amount that they're giving us, and we just simply solve this for x. We move everything to one side of the equation. Well, this is what we need to solve for x. You notice that I can divide each term by a common numbers here. So would be we have 15. 5 is in common among all these. 5 in common. If I factor a 5 out here, then I would get this. So actually, there was 5 out here. If I divide each term by 5, the 5 is gone. So you're really factoring that polynomial to 3x plus 11 times x minus 17. Then you can solve for x. X would be equal to minus 11 over 3. X equals to 17. Remember what the x was related to. X is related to a length, so it has to be a positive number, positive quantity. So a negative doesn't mean anything here. So x equal to 17 would be acceptable there. Since already greater than 17, that was a restriction. So the dimension should be 17 inches. The other one was 3 times that. So would be 3 times 17 would be 51. So we're looking at 17 by 51. So the product would be just plugging those numbers into this formula, and that you can see the answer is correct. For part D, it says what dimensions of the original piece of metal will assume a volume greater than 2,000 but less than 3,000 cubic inches. So it says ask to solve this graphically. So this would be a good place to use your calculator. So if you look at the graph of the function and graph of those two lines, 2,000 and 3,000, as you can see where they intercept, okay? The dimension should be between, okay, for y is equal to 2,000, the intercept would be 18.6. When y is equal to 3,000, the calculator shows the intersect would be x is equal to 21.1. So this would be the dimension. It has to be between 18.7 and 12.2 inches, which correspond to, well, the dimension for the length. Multiply that by 3 times that. So that would be the length. The length is between 56.1 and 63.6. So the this is another application problem that involves Pythagorean theorems. It's given to us that the longer leg of a right triangle Okay, they remember when you have a right triangle here, the side opposite to that 90 degrees is a hypotenuse. That's the longest side. And the other side would be like A and B. And there's a relationship here. Remember, C squared is equal to A squared plus B squared. That's the Pythagorean theorem. All right, they're giving us some relationship between these sides here. It says the longer leg of a right triangle lot is approximately 20 meters longer than twice the length of the shorter leg, and the hypotenuse is approximately 10 meters longer than the length of the longer leg. We want to estimate the length of the side of the triangle line. So let's picture this. Let's assume this side is x, right? The hypotenuse is 30 more than twice x, so it would be 2x plus 30. And the other side is 20 more than twice x, so it would be 2x plus 20. Okay. So this would be my three sides in terms of x. And now I can write down this relationship here for that. So the hypotenuse square would be this one, would be 2x plus 30 squared must be equal to x squared plus 2x plus 20 squared. So that's what we're going to have. The domain of x is between 0 to infinity. So here is my relationship here. The hypotenuse square, which is 2x plus 30 squared, is equal to the sum of the square of the other sides in terms of x. Pretty much to do the algebra, we just expand this. Everybody know how to expand a plus b squared by now. So that you can use the formula. That would be a squared plus 2ab plus b squared. You can use that for maybe this part. Would be 2x squared plus 2ab would be 2 times 2x times 20 plus 20 squared, which would be 400. So that would be this side here. And then we do the same thing here. The first term square plus 2ab. This is a 2ab plus the second term square. Pretty much you move everything to one side of the equation, and we can factor that. You get, I give you x minus 50 times x plus 10. So you can see x would be equal to 50 and x equal to negative 10. So the negative is not going to make any sense. It's not going to be in the domain. The length cannot be a minus. So if x equal to 50 is good, so it would be 2 times 50 plus 20 would be 120. 2 times 50 plus 30 would be 130. This would be the dimension of the other sides. So this would be another example here, modeling population data. The percent of Americans 65 and older for selected years is shown as this table. Okay, if x equal to the year 1900, we have this data here. The percent of Americans are 65 years older would be 4.1%, and in 1920. That figure is given to us as 4.7%, and all the way to 2040, the percent is given to us as 20.6%. So these are the information that we want to calculate. For part A, we want to plot data. Let x equal to 0 correspond to 1900. So this is where you're going to adjust the data here when you enter your calculator. So instead of saying that 1900 correspond to 14.1%, we're gonna say x. If x equal to 0, then the correspond to 4.1%. So this would get adjusted then into when x equal to 0, we put 4.1. For the next one, remember, if x equal to 1920, then that would correspond to 20 then. So this would correspond to 20. When x equal to 20, the corresponding value for y would be 4.7. and so on, all the way to, this would be 2040 correspond to 140, okay, would correspond to 20.6. So we're gonna adjust our data by that assumption that we have. So if you have your calculator plot the points, you can see these points here. So for part P, it says find a quadratic function f of x is equal to, for part B, the quadratic function is f of x. Remember the general equation of the quadratic function is equal to a times x minus h squared plus k, that model the data by using vertex equal to 0. The vertex is equal to 0 and 4.1 is all given to us. And the second point, they're giving another point when x is equal to 140 and y is equal to 20.6. We're going to use this information here to find a actually. So going back to part B, see, that's what they're asking you. Find the quadratic function f of x equal to a times x minus h squared plus k that models the data by using the vertex being 0 and 4.1, and they're giving you another point here to calculate a. So that's what we have. So what we're going to do here is to say when x equal to 140, this is when x equal to 140, y is equal to 20.6. So f of 140 is equal to 20.6. I'm going to solve for a. So this is my formula here. F of x equal to a times your x is 140, your h is 0 plus 4.1, and that's only unknown here is the a. The only thing that you don't know is a. You solve for a, so there it is. So now we have the coefficient of a. So f of x would be this formula in terms of x. And for part C, it says graph f as y1 in the same viewing window as the data, and how well does f models the percent of Americans 65 years or older. So this would be pretty good fit here for most of the data fits in here. So I would go with that. And for part D, it says use f to determine the percent of Americans 65 years or older in 2020. So kind of predict what's going to happen. So for 2020, x would be equal to just plugging into that formula. The difference would be 120. So we're talking about f of 120 when x equal to 120, what would be y? So as you can see, we can predict that would be the model. Predict that 16.2% of Americans will be 65 years or older in the year 2020, which would be a good good prediction based on the formula we have. So for part E, we want to use the quadratic regression further of the calculation using a graphing calculator to determine the quadratic function g that provides the best fit, and graph g as y. So as you can see, we can ask our calculator to find the value of a, b, and c, and as you can see, finding this, we can approximate these values here. So y would be equal to the value of a is calculated to be 0.004985. The B is calculated to be 0.04527, and C 4.054. So that is our best fit